using the principle of moments, the clockwise moment due to the gas will be equal to the anticlockwise moment due to the solid. The moment is calculated by multiplying the force by the distance from the pivot. In this case, the weight of the solid times the distance from the pivot, and also the weight of the gas from the distance from the pivot. Since the weight are equal, then that means that even though the temperature increases, only the volume changes, but the mass remains the same. Therefore, the weight will be the same. As a result, there will be no change recorded. Moving on to question number 2. Since the arrangement is in equilibrium, we are going to apply the principle of moments. That is to say, the clockwise moment due to the tension, the anticlockwise moment due to the tension will be equal to the clockwise moment due to the weight. Since the rod is uniform, the weight acts through the center, which is 30 centimeters from the pivot. Hence, clockwise moment due to the weight is W times 30 centimeters, and anticlockwise due to the strain is the tension multiplied by the distance. Substituting the values, we have 8 newtons times 30 centimeters should be equals to 4 newtons times D. D is what we need to find. Dividing both sides by 4, we end up finding that D is 60 centimeters from the pivot. And therefore, it will be 60 plus 20 meters from end A, which is 80 centimeters. There we have it. It wasn't that hard. You can try another question. Let's move on to question 3. To start off, we need to find the tension on the right side by looking at the effort, which is 100 newtons, and the tension T2. The tension, which is acting upwards, will be equal to the sum of T2 and the effort of 100 newtons. The tension T2 is equal to the effort since it is part of the same string on the pulley. Therefore, T will be equals to 100 newtons plus 100 newtons. This gives us T equals 200 newtons. We can then use this to find the force that is acting at the piston. Since the beam is in equilibrium, we are going to apply the principle of moments, which states that the sum of clockwise moments equals to sum of anticlockwise moments. We will take the clockwise moment due we will take the anticlockwise moment due to the tension and equate it to the clockwise moment due to the force, and therefore T times 3 will be equals to the force we want times its distance from the pivot. We take the fulcrum to be where the tension by the string here balances the beam here. And doing that, we find that F is equals to 600 newtons. For our last question, we just have to apply the equation pressure equals force divided by area. Now, the pressure is 600 divided by the area. We have to first convert the 10 centimeters square into meter square. To do so, we divide by 10,000. Therefore, that gives us 0.001 square meters. So, our answer when we divide is 600,000 newtons. Thank you very much for watching this. Welcome for the next session. Thank you.